Good day, everybody. I hope we're streaming, and we'll find out in a minute here. Somebody wants to comment that it has started. Ooh, I see it. There it is. I can see it myself, so good. Hello, everybody. This is Tuesday night as my live stream, and I see a few of you there. Mike Bertelson, who joined me last week, was commenting, so... I know that Fight the Flat Earth and Team Skeptic are doing a live stream right now, so maybe some people get sent over afterwards. But hey there, Linda. So I'm gonna do a little bit of housekeeping first here. We're gonna set up. We're gonna do gonna review videos today. And Mike had sent me one, and I got a couple others queued up. And Sleeping Warrior put out a pretty rude video earlier directed at Conspiracy Cats, so we might review that a little bit. And hey there, Demonic Davros. Good day, Globeheads and Conspiracy Deniers. Perfect. So last week we talked about gravity, and... I don't get a whole lot of flurfy comments, but I get a few. So Gleam, who claims that he's not a flurf, he says that he's a mock earther, whatever that means, like that everything works either way. Silly, but fine. He had a whole bunch of junk on gravity that he posted, and articles written by people that do not deny gravity, suggesting that they would somehow... deny gravity. And so I just asked him simply, could you, or he's like, which gravity? The Newtonian or Einsteinian? And like, well, it's both. There's no inconsistency. They don't disagree with each other or anything. So I always find that funny that they think that they have some sort of gotcha because they ask Newtonian or Einsteinian. Of course, the difference is in Newtonian, that's what we experience, and that's at the level that we see, where and it's a law, right? And if you look at the character of a law, it's not about what is the cause of it. The law doesn't care about that. Law is we observe things, we make predictions, we have a model that works, and we don't have any conflicts. So there it is. We call it a law. But it takes a while. You don't just get there quick. So Gleam, if you have some way or showing that gravity doesn't work, how mass doesn't attract mass, outside of any, what galaxies do and what neutrons do when they interact with protons and electrons. That's not what we experience. That's not what the law of gravitational attraction talks about. So, hey there, I see Sean Hawkins, Zeptepi. Flat Earth contradict every single law of physics. Yeah, that's a great point. That if the Earth were flat, it would be basically dozens of Nobel Prizes. Like they say the moon puts out cold light. Well, there's right there for you. There's a pretty awesome Nobel Prize. If any flat earther, you get some real evidence of that, come talk to me. I wouldn't mind a Nobel Prize. So we have, let's see, I'm going to start with a little video here that I have from CC. If you guys, hey, Terry Davies. If you know CC, that it's a car driving flurf, of course, from New York. And he says, there are no satellites.
Good morning, good evening.
So I will we'll pull this up here. I think it's pretty funny. It's a 10-minute, 11-minute video where he doesn't actually get to the point of saying there's no satellites. He actually doesn't do a whole lot. And I think it's funny. So this isn't in a car. He's got his crooked sign there. He couldn't fix
I want
before
to show you something
the video.
On the old dinosaur right here.
So is the sound okay on this
I'll give you
one?
an introduction to it, where I came about finding this out. It's not hard to find either, and I'll tell you how to find it. Last night I was
Good morning, good
place,
afternoon, good evening.
to do and stuff like that, and I had Survivor or something, Man or something like that on.
Yeah, what does the satellite dish point at? So, all right, we'll skip past this here, and he gets to this poorly framed part of his video where, all right, sound is good, thank you, where he's showing Google Earth, and he thinks he has something. Now, remember, I'm a programmer. I'm a software engineer for quite a while. So when he's talking about a little bit here about programmers, you know, it's something that I'm pretty familiar with.
Let me show you.
Okay, so I can't really look at this because if I reverse the camera to turn this video off, but I did find one pond here. It's called Huff Pond. And if you zoom in, you could actually see clouds.
So I missed the beginning of the part. He talks about how on all these satellite pictures there's no clouds. Of course there's no clouds. You know, if you want a good picture of your house, you wouldn't want it with clouds in the way. You would take a bunch of pictures and choose the one that doesn't have clouds. Somehow that confuses him. He thinks maybe you can only take one picture, I guess, from a satellite. Now, just to be clear, there are pictures from planes. And pictures from planes don't disprove that there are pictures from satellites. They're both. So
now, that would be impossible if we lived on or it would be impossible if we had satellites up in space.
okay. He says it would be impossible if there are satellites up in space. Maybe you guys can help me find out what he's talking about here.
Okay, so I can't really look at this because if I reverse the camera to turn this video off, but I did find one pond here. It's called Huff Pond. And if you zoom in, you could actually see clouds. Now, that would be impossible if we lived on or it would be impossible if we had satellites up in space taking these pictures. Now, you gotta...
So, anybody have a guess what he means by saying you couldn't take pictures of clouds if there were satellites? I don't quite understand what his point is. He didn't really get into it in the part ahead of it. He just basically said that there's no clouds. So I think what's happening is they are being careful to have pictures that don't have clouds when you're looking at a houses and ground and stuff like that. But when you're looking at water, it doesn't matter as much because there's no surface features to look at. So I don't know.
Search.
And
you
why couldn't
search.
he
You
just
gotta
frame
find
this
these
better?
little ponds like this. You know, not all of them are going to be like that. And I'll tell you, this computer program's very, very good because look at all the smudging there. There should be a reflection right here of some sort. There's not.
So again, why should there be a reflection of what? Of the satellite or of the plane or of what? I don't know. It just does. He's not really making a point here. I don't understand. And then, all right, so the smudging is, of course, there's a lot going on when you do these maps. You have lots of pictures, so you're building a panorama, like when you take your phone and you sweep across some area, and it stitches together all of the images. So it finds similar areas and stitches them together. And anywhere you have a border like that, there's going to be an issue. There's going to be some anomalies in that overlap. It's not weird. It's not unusual. It happens when you go to a football stadium and take a panoramic view with your phone. And then the smudging, he's probably talking about JPEG compression. So when you compress images, you want to make them small, and there's two ways to do it. There's lossy and non-lossy, or lossless. So lossless compression is image formats like when you store things as a Photoshop document or a TIFF, or sometimes in PNG files. You can store them lossless, and you can store lossy, which would be JPEG and MPEG video compression. All the video compression we use is lossy. There's errors that it introduces, knowing that our eyes won't see them very well. And as you increase the compression, there's more and more errors in that in the image, but you get a smaller image file. So when you're storing lots of images of the entire Earth, you do want to be careful on space. So that's what they're doing to balance between the quality of the image and the size. So you'll see these artifacts in JPEG compression.
All you see are, pixels basically. But when you zoom in on this house, you see it perfectly. I could even make out that freaking car right there, I believe. I mean, what is that? Is that a Lexus? So zoom in on little ponds that you can find, and you will see it. Let's see if we can see it here. This is the reservoir. Now, reservoirs, you're never going to be able to see it. See how it's just completely pixelated? But yet around the tree.
So he's actually, it looks to me like it's actually like waves. I can't be sure because it's not a great picture from him. But I don't know what he's finding here. So I think it's pretty interesting that he thinks there's something, but there isn't. I think it's pretty typical of flat earthers that basically they take their misunderstanding of something and think that they have something. So anyway, he keeps going, and then in the end, he gets off track on other things and never really explains why there's no satellites. So he says what we know. He says that there are planes that take the pictures, but we knew that. So all right, here's another one. This one is great. He does his typical vertical video.
Okay, so what I wanted to do,
but then he turns it sideways.
They're at the restaurant. They're all looking at me, and that's fine because the Earth is flat. Just to let you guys know. But you know what I was trying to get here? A perspective of the banister and the ocean. All right, this is probably the best way to do it for you guys, because if you notice, the banister is right there.
Let's see if I can rotate this.
Let's take a look at it, and the ocean's in the background. And what I was checking out is, look how flat that horizon is right there. I mean, I don't see a curve at all.
All right. How high do you think he is here? I don't have a way to rotate this in VLC that I'm finding. Right? How high is he here? He's got to be. That's the water right behind him there, and there's the beach. So me and Cece are competing with Chris Cuomo right now. Cuomo? I don't know who that is. So it could be, well, he could be on the side of the ball there, Stringer News. I see. But so I like this. He's lining up the edge of that banister with his phone, and he's expecting to see a significant curve. Of course, did he do the calculations to see at the 10 feet above sea level how much curve he would expect? There are things that we can find online to do that. No, he didn't. He did nothing of the sort. He just figured, well, there should be curve. Therefore, if there isn't, then and I can't see it with my naked eye, then whatever. Yeah, Linda Bertelson saying he seems to be about 20 feet above the beach. Whatever. So, if you saw my debate with Russian vids, you'll know what's coming here. Let me pull up my. So Rory, another YouTuber who was with me on. I spent a year before I did anything on YouTube. I spent a year on TFES.org, the Flat Earth Society.org forums. So let's see, Horizon-O-Matic. So here is the Horizon-O-Matic. Let me get. Wrong one. So, I'm just not quite proficient in OBS yet. Anybody else out there getting good at OBS? Because there we go. There it is. All right, let's transition that. So that picture's a little big, but that's fine. You can see the setup here. That is Rory's setup. There's 2 straight edges there, taped together on either side. Let's see if I zoom into, yep. You can see here when we zoom in real close, you can see these 2 straight edges. They're taped together. Yeah, actually, I think there's zip ties, a bunch of them, because in an earlier version of this, he had Curve Pimp. He works in government security, so he knows who's watching. Watch out, Gleam. We know who you are. We know where you are. Our drones are hovering over your house right now. So this is the setup. And let me, you know what? Let's get all these here. Did that. So let me go back to Goofball here, Cece's video, while I do a couple things here to get the sidebar thumbnails. There we go. I think that'll work. I have to change the there we go. And now we can switch. There it is. All right, so here we have the horizon-o-matic with the horizon right there on the gotta find the right spot. When you zoom in, it's hard to find. So here it is, right on with the 2 straight edges above and below the horizon. Now, so we had I was showing this to Flat Out Hero last week, and he instantly was like, oh, there's a bulge in the water. Like, that's where you go to, huh? This is a pretty calm day. You can watch a video of it. So anyway, you can measure the pixels here between the bottom of the straight edge and the horizon, the top of the horizon, or the top straight edge and the horizon, and you can see it rises up there, right? From the left to the right, it moves up. And it keeps going. We have this gap between here, and now we have the straight edge again, and there it's up high, and we're going to see continues to curve, right? Of course, it's hard to see in there because we're zoomed in so far. But when you zoom out, or sorry, when you do the simple compression, that's what you get there. You see the whole thing does have a curve to it. And this isn't any fakery. This is just taking what's hard to see, and we could measure it. We could write some software, in fact, and AB Science maybe would be interested in that. Mr. Unite for the Children. Earth is flat. Now you kids get off my lawn. How can you yell that from your basement? Your mom's basement. So, all right. So anyway, here's just for CC. And I commented on CC, so I haven't seen him in here, but I said this is kind of silly. I'm going to address your video. So anyway, this image here is taken from 609 feet above sea level. I do have this. Oh, Gary. All right, Gary, stop copy pasting. Gary Wybenga is here. So, Gary, maybe you can address this image right here. So, what was I saying? The compression isn't doing anything trickery. It's just making it so that we can see it with our eyes what's hard to see with our eyes, because when you zoom in, you can't see the entire thing. So, and software can do that for us. And I asked Cece, could you, if you want, you can show up and tell me, join in, but I don't see he's here. So, and so Gary, what do you got? Anything for us here? You see this nice curve in the horizon? Anything? Yeah, you're gonna come up with some limit of angular resolution, something. Yes, Gleam does provide good humor. He's I gotta say he's a little different than the flat earthers. He's not scared of science and math like most of them are, so that's good. But Gary Wybenga, scared of math. Definitely scared of math. I challenged him last week, and maybe Gary's here to present me with his predictions for gravity at different places around the Earth. Like the formula we have that predicts gravity. I'm sure he has it, right? Probably not. So, all right, what else do we got here? Gleam and CC, and then we've got nothing yet from him. All right, we've got a video from that guy. Anybody watching that humor? Let's see.
What's up?
So he has nothing from Gary. Was this just a flyby? You just fly by, do a copy paste, and fly out? Let's see if he's here. Oh, you're still here. Let's see that prediction. So, I have, as you know, I've been working on a $10,000 challenge. It's a lot of detail, so I've been careful. I don't want to put it out early. For gravity. So if there it is. Bottoms yeah, Gary, I didn't ask you about bottoms disappearing for your reasons that don't actually work. And I have the same thing for you, Gary. A predictive explanation for bottoms disappearing first. And I challenge you to that. Not this week. I'm not. That's not my topic. But maybe next week you can come back. You can join me, and we'll do that, right? Live. You can bring your model. I'll bring my model, and we'll see who has the least, has the most accurate model here. So, all right. That guy, let me transition this here. So that guy in the back of his truck, I'm trying to Scott Meyer, you should not have come here for me. Stay and watch. Now you're gonna fool. Just don't talk to me and I won't to you. Oh, what's wrong with you, Gary or Gleam? Scott Meyer is bored of you. So, all right, here is that guy, and so he's talking about gravity, not gravity, magnetism, the Earth's geomagnetic field.
YouTube, your favorite dickhead, I guess.
Correct.
It's all in fun. I don't mind.
Since Right the Hand is kind of, he's in and out of the Discord, and he's too much of a interrupt monkey to have an actual conversation. I think that guy's got to be our favorite one.
It's fun. We're all having fun here, right? People ask me why I use a stick to show what a compass does. Because a compass uses straight lines. A compass, this is the line a compass draws. It's not pointing out here, then making an abrupt turn to point to here. See what I'm saying? If this is the North Pole on the sphere, this little sticker right here, this is the line that a compass draws. Whether people understand that or not, you will never convince me that this line is actually looping over and touching this.
So we can never convince him that magnetism works the way magnetism works. Yep, Dunning-Kruger there. Nobody's arguing this. There aren't even flat earthers that are saying that magnetism doesn't form loops. So I have here my stack of magnets. If you saw my magnetism video where I what was that goofball's name? Patrick Shank. He challenged me, and I instantly, easily put magnets in a. He's like, you can't do it. You can't make it replicate the Earth's magnetic field with a compass on a ball, and it was easy. So that's what that guy is about to say.
Looping around and touching that, and looping around and touching. The compasses lay flat. They point horizontally. Every argument I've heard so far is that I don't understand the compass, I don't understand magnetic fields, they align with the magnetic fields of the Earth, and not really explaining how a compass that must be laying flat, that only points in straight lines, right?
So here's my compass. See if you can see it here. It doesn't work when you go this way, but you can see behind me is north, right? I'm going to see if I can get this to work here. So here is my stack of hard drive magnets. Right? So right up there is the North Pole. I think that's north. Nope. There it is. We have north. Now you can't see that, I know. But if I do this, you can see it's north, right? So when I rotate it around like this, look at that. It still has north pointing that way. Now, it's hard to know. I'm not sitting on a ball, but it works that way. And if I twist it, it changes, right? So magnets put out a three-dimensional magnetic field, and apparently he doesn't believe that. He doesn't understand it. So, his lack of understanding is not our problem, not my problem, and it doesn't disprove anything. It just shows that he doesn't understand magnetism, which is fine. So, yes, I write software, so dead hard drives show up, and I tear them apart, and I had to go through a lot of hard drives to get enough of these similar ones, and some of them, they have this. I love these magnets. They have this little nub here. You see that? I have to take that off, and so this one didn't come off very well. But the good ones, I can get it all the way out. So there you go. Nothing sticks out. And I use these. I love these for finding for a stud finder in the wall, because it finds screw heads pretty easily. So. All right, let's listen up on this guy.
Compasses work horizontally. They don't point in every direction away from it. It's not like this is a compass with lines going every single direction, right?
Wrong. They just are. Don't. You can't just make a claim and then it's true because you don't understand it, right? Try to understand things a little better.
It's literally a needle with iron filings being drawn to a certain point. Wherever those iron filings are pointing to is literally where it's pointing to. You know what I mean? It's a compass, people.
Yeah.
We're not.
So compasses have, and if you've seen, if you have time, check the, okay. Magnetic games. Ooh, that looks fun. So, should I play that, Mike? Is that, I'm going to have to download it first, so. Entertain yourselves for a second. Online, I got to download the. That's not it. YouTube, download. There it is. There it is. Hopefully when I download this, it doesn't interrupt the stream, but it should be pretty quick. I have a lot of download. The upload is the issue. There's the download. Done. All right, I'm going to switch to this. All right, Mike. Got some sticks. was at about 55. All right. Seconds. That is pretty cool. A three-dimensional magnetic field there. That guy, how does that work? It looks like all those pictures that people draw. That's cool. I'm going to save this one. I like it. Reverse. That'd be a mess to clean up. Like when I take apart hard drives and if the head has crashed and it scrapes all the junk off the surface of the head, it's a mess of iron filings inside, and the hard drive the magnet's just coated with this thick, really fine dust, but it's a thick layer of it. It's nasty. I don't. If I open up a hard drive, I just chuck that one. I don't try to get the stuff out of that. So, all right, that guy. He had a couple things on magnets, but I think he just doesn't really have an idea. So, Gleam, what are you talking about in here? So, Zeptepi, if you think physics professors would not figure out if you just left the words out. Ha ha ha. And no, you won't fall off the globe, as Walt Disney invented gravity. Walt Disney invented gravity. Super. All right. Oh. Zeptepi, or Gleam again. Zeptepi, you're silly. I'm only asking for the publication you think exists would never peer review a flat Earth paper. Are you being silly or unrealistic? Yes. Nobody would peer review a flat Earth paper because there's too many assumptions that you'd have to first have, right? So if you wanted to introduce flat Earth into science, you'd have to go with the underlying principles. Like first you'd have to somehow figure out how you can explain gravity, right? Of the four models I'm aware of the flat Earth, there's only one that allows gravity, really. And that's the infinite plane model, where there's a thin plane, but there's other issues like why do the sun and moon stay up there, right? So if you're going to go to trying to introduce flat Earth into science, you can't say the sun and moon just go up there, and never mind that, we're going to go with this other stuff and explain these things for you first. And please peer review that without paying attention to the nonsense about the sun and moon staying up there with no reason, right? So I don't know what you're going to do. So, all right, that guy, let me get back to this one here. That guy has, he went on for a couple weeks on pressure. And if you've watched, he really, really doesn't understand pressure. He thinks that 0 is the neutral point between high pressure and low pressure. And low pressure would be like 0.1 or 0.01 or 0.001. And that low pressure actually pulls. And just like cold light, it's impossible, right? There is an absolute zero temperature. There is an absolute zero pressure where there's nothing. So pressure is stuff pushing on something, and if there's no pressure, there's nothing pushing on it. It's not a pull, it's nothing. So anyway, he says that because he thinks that the Sandusky pressure chamber, the big 120 foot tall one that NASA built in the 60s, it needed these 6 foot thick walls of concrete in order to protect itself from collapsing in, and certainly there's a lot of structure needed because of the size of the chamber. But the 6-foot thick concrete walls was because they were planning to do nuclear testing inside the chamber. And if you're doing nuclear testing, you want some protection, some prevention of getting the nuclear radiation out. So, but now if you do the math on the pressure, 14.7 psi on the outside of a 120-foot tall wall, that's a lot of pressure. And you do have to, on the outside, right? There's none on the inside. There's a lot on the outside. So you have to build a strong structure. There's no question about it because of its size. So I asked him, so he's like, well, it's 10 to the negative 6 torr. And he's like, that's a magnitudes more powerful. So I said, well, what about a vacuum tube? And he never answered me. No surprise there. That guy never answers a challenge. He basically just swears at people and tells them they're stupid for believing regular, normal things, and that he's some sort of a genius because vacuums suck. And Paul on the plane had a similar thing. Anyway, so I say, what's the pressure inside of a common vacuum tube? He did respond to that. He said, there's no such thing as a common vacuum tube. I'm like, well, of course there is a common vacuum tube. People don't use them much anymore, but they do a lot in today's high-end guitar amps and in some very specialty audio equipment. You could probably even ask Nathan Oakley about, pressure or vacuum tube amplifiers for home stereos and how expensive they are. So I have here a common vacuum tube that has regular high-end amps as well. Scott De Leon, is that how you say it? De Leon? There, Stringer News 1, 6L6, exactly. So I have designed my own guitar amp. I haven't built. My guy at work did it. I bought for $20 an old organ, the same organ that Led Zeppelin used on their first and second albums. And it had mostly bought it for the vacuum tubes and the rectifier, not the rectifier, oh my goodness, steps the voltage. Why can't I think of that? Holy cow. Come on. Help me out there, Stringer News and Mike Bertelson. Anyway, so yeah, this, I don't know if this is a 6L6. I can't, it's a little rubbed off because this is a pretty old one. This says BA6. 6BA6. There it is. You really can't see that in the camera. So that's a 6BA6. And then this one I pulled out today from the organ, sitting at work actually. It's a 5U4. This is out of the power supply for the organ. So we have the little guy here and the big guy here, which is for power. So I asked him, what's the pressure in there? He didn't answer. The answer is, the good ones, which should be anything that's going to work well, is 10 to the negative 6 torr. Yet how can all that suckitude be held in there in this little tiny glass? It's not 6 feet thick concrete walls. So that guy, explain with your power of suckitude how that works. You can't. I know. You won't. You'll call me an idiot without providing any supporting evidence. So, anyway, moving on. I think that's enough of that guy for now. He is a comedy show. This is sad. So, let's see. I have an image here. We're gonna go to. It's so I have a Facebook account for MC Tune. If you will want to look at that, it's just Michael Tune. It's if you I'll take any friend request. And I don't know if people might find you through me. If you're troubled, don't do that. But you can find, and I interact a little bit on there. Try to get a little bit of interaction. It is interesting how there's different these different communities, right? Like the TFES.org community, they try to use science, right? Like they don't. Sleeping Warrior's nonsense about gravity. He doesn't. They're like, no, that's not. You can't just say it doesn't exist. You have to actually like have an answer for stuff. So, let's see here. There it is. So, here is something I found very sad. On Facebook, somebody posted a picture of their kids at a science fair. And I covered their face. They put their face on Facebook of these kids. You can go look up their name if you want and find them and tell them don't do that. But I posted, and this guy, Earth is seriously flat. If you've ever seen him, he's always talking about going to tell kindergartners about flat Earth, and I'm like, quit it. It's not flat. It's just your silly delusion. But so here, flat Earth. We are beyond proud of these 4th grade young men. Flat Earth project at the State Fair. The FE model has an actual magnet button in the center pole, which of course doesn't really work. With a carpet tack representing Mount Meru, which doesn't exist. But there's an annual marathon at the North Pole. So people go there every year. There's a guy that I want to interview that was at both the marathon on the North Pole and the South Pole. I don't know what got to look where the actual South marathon is, but it's on Antarctica. So there are people that want to run a marathon on all 7 continents. So anyway, there's no Mount Meru. So a foam ice rim for Antarctica. A flashlight shine to show the true path of the sun, which is not the true path of the sun. You can ask anybody that lives in the southern hemisphere. Does the sun rise in the northeast ever in the summer? The answer is no, it never does. It always rises in the southeast, which the flat Earth model doesn't predict. Well, at least this particular map. Some good memes blown up with Aries failure and Florida's missing curvature. I don't know if there's any particular Florida missing curvature, but I saw Red Rhetoric's curvature. That looked pretty good. It wasn't missing. A common sense as well as a biblical FE explanation sheets. A carpenter level to show how water is always level. A basketball ready to get wet to show the non-gravitational spin. And best of all, 2 great big smiles. Lol. Great job, FE project team. Now, if I have to ask, if you were the judge at this science fair, put in the chat, what would you give them? Would you give them a blue ribbon or would you fail? Here's my answer. And I don't care. I want the parents, because science projects are parents, really. I did a science project. My parents did it in 4th grade. But yes, fail. And the parents would get that message, and you certainly wouldn't. Scott DeLeon, I'd smash your project and tell them to start over. So I'd bring this globe I have right there. Bring it to them and say, here you go. Let's just swap that out for something that works. But here's the problem. And if you can see here, these kids are going to have to get jobs. And if you're telling them all this stuff that runs opposite of science, they're going to show up at a job. They're going to say Earth is flat, and in the interview or whatever. But I got to tell you, if I worked with somebody, if I had somebody I worked with that said the Earth is flat, I would seriously have a problem with them. Even simple stuff like they're going to use a ball and they're going to spin it to show that water doesn't stick to it. When did you do the math to find out the exact centrifugal force that the globe Earth predicts? You never did. Nobody ever does that. It's not much. I've done it. So Anyway, these kids here. Yeah, here's my. This is what I put over the image just for the live stream here. Yeah, flat Earth hurts kids because they don't know, right? They take what you say, and they don't know. DF says I'd give them an A at drama class though. Yes. Future McDonald's workers. Like if I was at McDonald's and I was a manager and you said the Earth is flat, you're out of there. You're not working here either because I don't want you talking to the customers saying the Earth is flat. No. So, anyway, and I told Earth is seriously flat, who is always in there saying that he does that I'd be debunking, or not debunking, just addressing it tonight. And so I don't see him here, but whatever. Sorry, it's not flat. Earth is seriously flat. Don't be telling kids that. So if I really like Richard Feynman, one of my heroes. One of my personal heroes is Richard Feynman. And I love listening to him speak. I have almost all of his books. They're up on my bookshelf here somewhere. I'll get them out for it. I have that gravity video. So, some people are happy to work with flat earthers. They work at the asylum. Oh, hey Globe Flicker. How you doing today? So, let's see. Wow, imagine if you actually accidentally gave a job to Nathan Thompson or Flat Earth Asshole before you realized how much they wanted to talk about Flat Earth. Yeah, you gotta. That's due diligence when you're hiring people, right? Because it's if you let them go, then it's a pain in the butt for unemployment and all that. So because they're not getting another job easy. So, oh, Earth Flicker, or Globe Flicker, what are you doing in here? He's meowing. He is saying levels. I'm good with levels. So are you talking about the audio? Thank you. I appreciate that. And, yep, hello. So I have now the user submitted video sent by Mike Bertelson. So, I haven't looked at it. I did see this topic on the Flat Earth Society forums. Oh my goodness. Mike Burleson. Orphan Rez says she can't wait to discuss Flat Earth at a Mensa gathering. Oh, that's great. So, and Stringer News says here in the Bible Belt, a lot of parents wouldn't see a problem with it, with Flat Earth. See, most people, most people are normal, and whether they're in the Bible Belt or not, they don't believe the Earth is flat. That there's just this super small minority, and centuries of people that are experts in the Bible, and they're not going around saying the Earth is flat. They are looking at those passages and saying, yeah, that looks like an analogy, right? Not a science book, but whatever. All right, back to what Mike sent me. So I had seen this on the Flat Earth Society forums, but I didn't look at when it was actually done. Let me pull it up here. There it is. It is Jaron talking. Oh yeah, you have to.
There is. It's right above you, straight above your head. So if any light is coming directly down from straight above you, that has the least amount of refraction. It has the least amount of effects. Those rays are going to come at you parallel if the sun's right above you. And then if you look to your left or right, or straight ahead of you, or behind you, that is.
Oh. The light on the ceiling is still 11 feet high, but it moves away from you. It visually lowers perspective. Absolutely. The law of perspective is at play here.
Is the most amount of atmosphere. So right away you can tell if the least amount of atmosphere is above you and the most is to your sides. That creates a personal atmospheric dome.
Oh my goodness. So, yep, it doesn't, but it certainly, if you're going to say that it affects because it's going to cause refraction because of the index of refraction gradient between the high up where there's basically no atmosphere and the index of refraction is 1, and near you where there's been an index of refraction gradient based on temperature, pressure, water content, carbon dioxide content, and other factors, but those 4 are the main 4 that you can use when you calculate the index of refraction. Yes, there is a gradient that comes down, and it does affect things that are on the horizon or closer to the horizon more than things that are straight above you. Yes, things that are straight above you are generally not having an appreciable modification due to refraction. So
all see through it. No matter where you're at on the Earth, no matter North Pole, South Pole, wherever you might be, you exist inside of a personal atmospheric dome where everything renders to you. So nothing can just appear in the sky. It all has to come from far away. So that's why we see things come up from the horizon line, right? And so this is a dome. We see as a dome. And if you think of the sky being a plane above you, so a plane of
an airplane above you,
stars above you, as things get further, since you're looking through more and more atmospheric distortion to see them, things appear to bend down towards the horizon line.
And that is where he didn't do his homework. He didn't do what flat earthers say you should do. He didn't do his own research. He took what he wanted, didn't do any research, and just said it as if it was true.
So that's the personal atmospheric dome. And when you understand that, then you realize that no matter where you're at on Earth, you see the sun rise to the east of your personal atmospheric dome and set in the west. And so people get very tripped up and they say, well, what about in the south? Isn't it the opposite? Where it's just, no, they are looking north. And so things rise on their right and set on their left, whereas us in the north, we look south and things rise.
Okay. I think he's trying to cover a whole bunch of things at the same time because the flat earth model predicts that the sun would rise in the summer in the southern hemisphere. The flat earth model says the sun would rise in the northeast, and it rises in the southeast. And so he's trying to use just a couple words to play around with that. It doesn't work. He doesn't actually give any answer that's satisfactory. But so he went on about refraction, and now he's going back to perspective. So he likes to flip back and forth between these. But I can I want to do this here. We're going to look at refraction and what it does in the atmosphere. So I got to find, I have too many windows, so I got to go find, there it is. That is it. This is my browser. Did it show up correctly? Yep. This is my website here. Here you can find, if you want, some Earth-shaped counter and the Earth-shaped field agent, Office of Strategic Influence gear. I got a T-shirt and a sticker and a mug. I have my mug right here. Let's see, I was drinking from it last week, and my shirt came. I was gonna wear it today, but Batman got the win today. Here you go. How does downward refraction affect the apparent position of objects? So I have a video in the works on this, and what I like to do is I like to write out the script and do all the footwork ahead of time, and sometimes I'll do a I'll make a website. So this is the website all the way down here, right? All the images in. And so, all right, let me pause that for just a second, because Zep Tepe says, a flurf here says that he has proof that southern stars are reflections of the northern stars. What do I think of that? I I think he doesn't have proof. Who is it? Who is this guy in here? Zeptepi. So let me scroll back a little bit here if anybody knows. Is it Globe Flicker or is it somebody else? Progressive Liberal. No. Stupid Monkey. How you doing? Logical Troglodyte. Hey, if you're not subbed to Logical Troglodyte, you better do that right now. Good stuff there. And AB Science yesterday had his 500 subscriber special, and he listed off a bunch of channels that you should all go subscribe to. I went through his list, and I found just a couple that I hadn't been subscribed to already, and some good stuff. So no, all right. So Zeptepi, do we know who this guy is? Anyway, all right. Here's the deal, dude. My email address is right on the screen there. No, it's not. mctoon.net. I have my email address there. You can join my Discord server. Contact me there. You can go to my Twitter, which is mctoon27, or you can email me, mctoon@mctoon.net, with your proof, and we can talk about it next week. You want to come on? We can do that. Otherwise, I will take your stuff and I'll analyze it, and we'll see what we find. So, all right, back to downward refraction. So, there's a lot of confusion about downward refraction and what it will make it look like. I heard Nathan Thompson in a debate say downward refraction will make things look down farther. He's just going off of words, apparently. He didn't, of course, like all flat earthers say that they should do their own research. He didn't do his own research. It's not what it does. So there's many things that contribute to the varying index of refraction: pressure, temperature, humidity, wavelength of the light, carbon dioxide content, and other things. There are several equations there: Cauchy equations, Selmer equations, and then these Sidor equations and the Eldon equation. All those bottom ones are the best. It is one case here where we don't have a super duper accurate prediction, but it's very, very close as they've gotten better at this to predicting during regular atmospheric temperature, pressure, humidity, all that. Jimmy Callahan, I will meow for a blue wrench and go Viking on you. I don't know about that. Globe Flicker. Sorry. Jimmy Callahan, you bet. So, and where did Logical Troglodyte go? There he is. He is, he had to head out. But, again, if you didn't sub to him yet, go ahead. So, let's see here. We've got the, I'm just going to skip down here to the image here. And, I got to update this to make it clickable. But you can see here the image as we got Batman here. He's got the building there, and the building, the light comes down towards him straight. This would be what happens if there was no atmosphere. All right, let me zoom in a little bit. There we go. Then we've got what would happen if there is an index of refraction gradient, where it's the highest index of refraction near the ground and lowest up high. You'd see that same light beam from here would start headed towards Batman, but because it would bend towards the normal, it would wind up curving before it got to Batman. And he wouldn't see that light. In fact, he would see none of that light. And so what would he see? He would see a different beam of light that started out at a slightly higher angle. And that's the light that he would see. Now, you don't know the difference when you're looking at it. You just see it. You don't know the light that wanted to get to you hit the ground in front of you. But what happens, though, is that it changes the angle at which the light the light gets to you. So the angle that it hits your eye is the key. You're seeing a different angle. And so what happens is it changes the apparent location of the object. Right? So you see it. Right there, that little faint thing above the top of the hotel is what you would actually see. So you'll see it higher. An index of refraction gradient makes it look higher, not lower. Jaron. So he's back to now. Remember, he's switching back and forth between the refraction effect and perspective, which he's just talking about and not calculating.
On our left and set on our right.
Now I'm saying this, I haven't seen this video, but I've seen enough. Like P-Brain does basically the same video, and all the people on TFES did the same things. And so, hold on a second. People are talking Batman. Michael Keaton or Christian Bale? Ooh, that's a tough one. That is tough. Just not the new one, whose name we shall not be spoken or typed. Do not type the name of the new one, because I might just have to boot you.
So it is a personal atmospheric dome, and then you have to learn to understand that. So many people get caught up in the idea of here's the fooling part. You live in a personal atmospheric dome. That's what you live.
Okay. Here's what's interesting. He's got this side view. I like that. But he's actually making the sun go down in the orthogonal one, the one over on the right. The sun shouldn't be going down on oh my gosh, Bag Puppet is here. The sun shouldn't be drawn to be going down in the orthogonal view. So what he's doing is he's double applying perspective by doing that. In the side view, we should see it rising, staying high, not going down.
And that's what you see things through. They convince the world.
And strangely enough, he's not making those circles shrink in angular size as they should. For some reason, everything gets to shrink in angular size except for the sun. Don't know why.
That there is another personal atmospheric dome below you.
Oh my. He just said another personal atmospheric dome below you. How? What is that?
You live in, that's what you see things through. They convince the world that there is another personal atmospheric dome below you.
Oh, they convinced. Okay, so he's saying that he thinks that we have suggested that there is another personal atmospheric dome. No, I don't know what he's talking about. That's not true.
With somebody living upside down inside it. And that's the biggest...
Okay, so here he has... Why did he choose now? So like the sun doesn't... oh my gosh. The train is getting smaller, but why didn't the sun as it gets farther away?
Fooling point of the entire thing is that no, you exist in your personal atmospheric dome. That's how you see things. When you watch a plane...
And on the left, he also didn't... Neither of those showed it getting smaller, but he has them getting smaller in the stack that he has on the... What is he doing?
Fly off into the distance. It doesn't just fly straight up and then disappear.
Notice... All right, so he has two balls. Notice the ball that's closer appears bigger than the one in the background there. But the sun doesn't do that because it's magic, apparently.
The clouds, it goes down towards the horizon. That's the way everything works. Just like the sun sets, just like the moon sets, just like the sun rises.
Sorry. So two 4-inch balls, 6 feet apart. Then notice that they shrink less and less as the camera rises. Yes, the angular size is not linear. Wow. That's 9th grade math, dude.
It's just like the moon rises. Just like a plane coming over the
horizon. It's like it's a surprise to him.
As you might term that, but just means it's coming from far away. I can't see planes from where I live leaving the San Francisco airport. It's too far. Yeah. But as things get closer to me, I would see them appear not out of the middle of the sky, but from the horizon line, because it's finally rendering itself to me. It's big enough to come into my personal atmospheric dome. And that's the way the entire world works around you. It's hard to explain, I guess, the personal atmospheric dome for people to get.
Yeah, because it's BS. Oh, yeah. People say Jaron is a Poe. You know, I don't know. I go back and forth. Who's a Poe? Who's not? You can't tell. Like, that's the point of a Poe, right? If you don't know what a Poe is, it's that in extreme circumstances, you can't tell the difference between somebody intentionally being as stupid as possible and somebody that is that stupid. You can't tell the difference. And so, yeah, is he a Poe? I don't know. I need more coffee. Oh, hold on a second. Oh, I got a little more Irish beverage in here. I'm out. I need to restock on that if I'm going to be watching these videos. So, you ever have coffee with Irish cream? It's pretty good. Even better, and I found that the less coffee you have, the better it is. So, just a little research that needs to be done. Is there an optimal amount of coffee in Irish cream for the best flavor? My hypothesis is that the correct amount is 0. But I'm willing to test. Mike Bortleson. Roya has a couple of good videos listing the flat earther community, and it's pretty enlightening. Okay.
But one visual that I thought was really good is if you picture a really foggy day, so it's extremely foggy, and you're at a train station and you're reading the train schedule, and you would only be able to see, let's say, you can only see your own train schedule. You're looking at it, and then if you look any further, it's too foggy to see. So, but if you think about there being 10 other people at this train station at the same time, and everybody's looking at their own little document, well, they can read their own little train schedule, but to all of them, they can't see the other people around them. That's how the Earth works. That's how our atmosphere works. That when it's clogged up, like when it's foggy, you can't see very far. When it's clear, you can see a little bit further. But that's the same thing.
But that doesn't explain how on a flat Earth something would appear to set. I don't. There's nothing obscuring it. Why does it get obscured?
That we know that people exist, or other people are at this train station. Other people are reading their train schedule. But in your personal atmospheric dome that's fogged in, to you, you're all that exists. You look left, right, behind you, in front of you, and that it's all blocked. But we know that those other people exist. It's the same thing when two people on flat Earth are standing near each other, maybe 4 or 5 miles away, but to each other, the horizon ends before you can see the other person.
Right. So, like, if I'm looking off towards the sky and the clouds towards the horizon, the clouds in the distance look like they're stacked on top of each other, basically. And if I were to picture myself as a person that's directly underneath those clouds in the distance, they would look back in my direction and see the blue sky with all the clouds stacked on top of where I'm at. And so it is very much a subjective sort of personal atmosphere that we all live within.
All right. It's subjective, yes. A personal atmospheric dome is just a word trickery, word games to try to explain it. Oof.
And we don't necessarily see it or understand that it's there, but it's almost like we're all walking around with our own little, like you said, personal atmospheric dome. I mean, that's really the best way to put it.
Yeah, say it again. Say it again, guys. All right, can we find something? Standard refraction to geometric non-existent curve. Oh, this is going to be fantastic.
Like when you even have the own words from Mike West saying that, I must be assumed that the radio of the Earth is, growing up based on the object that you can see far away, because in the standard model doesn't match. And he admits that, that it's not something real, it's just a theoretical thing, trying to match the observations, like if you live in the globe and not, it's not.
So, all right, first of all, this guy, when he says globe, it sounds like he's saying glove. I don't know who this guy is talking with this accent, but they're going on. It sounds like he's going on Mick West and complaining that the calculations don't work, right? And so I always find it interesting that flat earthers, they don't understand margin of error, right? There's always a margin of error when you do a measurement. Always. And so they think that if there is a margin of error, somehow it ruins everything, and like you have to throw it all away. No, well, what you do is you just include your margin of error in your reporting, and then you do another test and include the margin of error in that. Everything has a margin of error if you're being precise. And when you have a whole bunch of measurements together and you compare them and you find out, does that margin of error, do they overlap? Oh, Well, a lot of the time they do. And if they don't, then you look at the outliers and you ask, is there something we're missing? Or was there an error that we made in the measurement? You don't just say, oh, well, I guess we don't know, the formula doesn't work, and throw it all away and don't bother starting again. Let's just give up. And that particular guess completely doesn't work at all. So that's a false dichotomy they set up. They say, I can see too far. Never mind. Let's ignore it. Let's say refraction isn't it. I can see too far. I still can't see as far as I would if it were flat, but I can see too far. And then they set up the false dichotomy of, if I can see too far, it has to be flat. No, a much more reasonable conclusion is, I can see too far, therefore the Earth must have a slightly larger radius than reported. Let me test that to see if that's correct. Definitely not must conclude that it's flat. And that's that's just their confirmation bias, right? They're not being honest about it. They're looking for things that match their bias. And that's it. And yeah, Zeptepi, what is Jaron going to do when he quits Flat Earth? Let's be honest. It's all he has. Yes. And I got to say, so I looked last, fall at his Patreon numbers. And I looked a couple weeks after the Behind the Curve video came out. And I didn't write it down. I think he lost a good chunk of it. So, hey, Zetetic Headache, non-existent curve. Is this really where you're at? I don't know what you're saying here, but by your name, are you serious that you are into Zeteticism? Something that it's quite ridiculous. Anti-science. So I don't do Zeteticism. It's quite ridiculous if you are actually of that mindset. Confirmation bias equals pop psychology, which never existed until 2012. Okay, you're going to need to provide your citation for that. If and he gives just a little eyeball. So, all right. Either he's a Poe or a flat earther that has no point. So, all right, we're going to move on
globe.
to this.
Right now it's like an inflate globe because you need to make it grow up based on that distances. But the real thing is that they transfer the standard refraction to a geometric non-existent curve. So they make just simply statistics for saying, okay, if you see an object that far away at that height, is because the globe grows a certain percent. But when this is my research, just like that, because for me, when I start to look at this kind of video at that time, because this is like a 2 year ago video that a woman filmed on the shore, on the shoreline, a sunset, right? So for that person filming the sunset, if she doesn't have any optical instrument to make a zoom, because our eye is a magnificent piece, of intelligent design, but we can make
get to the point.
A zoom. Your eye is a fixed distance range. So for the normal people, you want to say that like the sun is here, right? Where my mouse cursor is pointing. Mm-hmm. But when this woman make a zoom, you can clearly see two sources of light right away. You're starting to see this, glowy source of light, and you're gonna see this other source of light.
Okay, so it's a lens effect. He's going on that. Super.
So the woman asked, because maybe she turned around and said, hey, look, that is the moon. So that object in the sky is not the moon.
Planet X.
Exactly. And this woman, and I say exactly because this woman is like, a Nibiru believer. So she's filming without notice that is exactly when you're talking about apparent position and real position. And that is, if you start studying this phenomena, for me, and this is my interpretation, just like that, this kind of thing, you can recreate in computer based on a personal DOM situation. Because when I look this, for me, it's clearly, this is the actual position of that object. And this is a refraction. Because this is
okay. Maybe he can make a new Bitcoin, Flurfcoin or something. Yes. So he's saying that the upper one is the actual position and the lower one is the real position. No, actually that is just an effect of the lens of the camera. And different cameras will have different lenses, will have different places that extra sun may or may not appear. And when you look with your eyes, you don't see it because your eye's lens is different. Again, it's a flat earther not understanding how things work and drawing an improper conclusion from it. So yeah, there's lens flare, which I'd say is what is around the actual image of the sun there, and then that up higher one is probably when you have intense light bouncing inside the multiple layers of a lens. It could be now I'm not an expert in manufacturing lenses, but it could be the reflection of one layer of the lens. Instead of going in, reflecting going in, bounce, come out towards another lens layer, and then back in towards the camera sensor. Could be. It's certainly not a second sun or the actual position of the sun, because the sun's light has to get to you somehow. Why would that be the actual position of the sun? You need to make a case for that, right? Which he's not. He's just saying he's guessing. So, all right. This is, man. They try. They dig hard. It looks like FE core stuff, right? It's painful, man.
The camera sees something, and I put 4 cameras.
He goes on. How do these people go for so long? They're modeling it. Good for them, right? Most flat earthers, they just make stupid claims. And diffraction artifacts also look like that. But why would a camera catch something that you can't see with your eyes? Exactly.
They never hit render. And when they hit render, they don't use a volumetric software. So it's the same thing as this. Like the only difference is like instead of showing just wireframe lines, it's gonna show you colors. But you never compute volumetric lights. So these guys are, really a poor understanding of how 3D software works. So when you hit, in this case, I hit render, but I hit render in this software that computes a volumetric light. So that is why this just simply asterisk you're going to see as a light representation with the inverse square law situation, That is why the normalize check button is on, because when you normalize the light, you apply the inverse square law. If you don't, if you want to recreate like a science fiction light, like reach the confinity of the universe, you uncheck this and you're gonna have an unrealistic light behavior. So
okay, boy, they really dug deep for that one. Oh, this looks good here. Yeah, they like to look at different refractions.
This is a superior,
right? I always find it fun that they look at so we see this I don't know if it's at a looming or Fata Morgana or some sort of mirage, whatever it is, right? There's different names for it, but there certainly looks like there's some sort of extreme atmospheric condition going on here, and they like to look at those and think that it makes some point. For the most part, when you see an extreme like that, it means you can't make any point at all, because there's too much chaos going on there that you can't really be certain what's going on, where it's coming from, right? So that's why you want to look at stuff from higher levels and get out of there. So zetetic headache, confirmation bias. Yes. Yeah, I don't know what... I haven't seen you around zetetic headache, so are you... Have I just not seen you? Are you new? Where are you coming from? But the angular size of the sun, as Jimmy Callahan is talking about, Callanan, is an issue, and never seen anybody address it well. They just say refraction, but refraction through the atmosphere is layered this way, not this way, right? So, so it would cause things to squish or grow this way. It wouldn't have an effect this way. And zetetic headache says confirmation bias never existed before 2012 with a first-person citation. As if that has any impact on anything, right? Confirmation bias is real. When somebody coined the term, doesn't matter, right? And Linda Bertelsen is saying somebody coined it. Peter Wasson coined it in 1960. And Zetetic Headache says it wasn't part of common parlance until 2012. So what? Doesn't matter. Flat earthers weren't yapping a whole bunch until recently. And confirmation bias is huge in the flat earth community. Maybe that's why it's common parlance, because the flat earthers are out there doing exactly that, confirming their bias and ignoring everything else. So, all right, so this confirmation bias here is what we're seeing, is what Bob and Jaron here are all going to be going on. So anyway, so Zetetic Headache, you can move on from that. It's a straw man for sure, as Mike said.
Mirage and inferior mirage and Fata Morgana effect, and let me go a little bit more. Let me just explain this very quickly because I believe the video has the line, but it hasn't. Here is the camera. You can see the camera in this video, but to the right side is the camera pointing towards this paper object and looking through a recipe with water, salt water, and sweet water, regular water. But the camera, the atmospheric simulation, and the object is always at the same level. This paper is not, down of the actual view of the camera and rise up, like they trying to explain based on the Canigou effects or other object that is completely hidden behind the horizon in the spherical model and rise up. That you never can recreate, So let me just go a little forward. For example, I took this image from a movie, the Thomas Crown case, and here you can clearly see when the camera.
This is a good one here. You can see down low, there's plenty of atmospheric effects, and up higher, up above the what he calls the horizontal real. I don't know what if it's Spanish or looks Spanish to me. I don't know the difference between Spanish and Italian or Portuguese. So the stuff that's higher up is not affected by it. So if you take the and overlay a picture of those tall buildings there, then yeah, you'll see that it goes down way too far, and that the refraction effects aren't enough. It doesn't explain where it went, because that the building, the bottom of the building, is way too far below the horizon, and you see that more in more extreme examples. So. Oh, Brian Peck. It wouldn't be a dome. Brian Peck sent me something here, so well, I'm gonna have to wrap up here pretty soon.
Crane camera inside of the boat, and the camera just lift up and show more panoramic background, and then comes into the boat and film the character of the movie. But here you can clearly see how the building disappear and reappear based on the atmospheric refraction and the perspective and the height of the camera, but it's hiding behind an atmospheric layer. You can clearly see here. It's not because the camera go away or.
Yeah, so it's a good point. So let's do it when we're at an altitude so that you cannot see extreme stuff. So like Miles Davis has done, where he went and he took a picture of the top of a bridge that's many hundreds of feet high from a position that's the same height, and distance objects that are higher than that appear below, and that can't happen if the Earth is flat. So it's a good one there. So Zetetic Headache, as does any researcher. No need to put instinct in the pejorative. So I don't know what that means. I'm not following your conversation maybe, but hey, send me an email and send me your something meaningful, because sorry, you're not giving much meaning here. So personal atmospheric dome, funny. I seriously, I had never watched it. I just seen lots of talk on the forums about it, and I'll say, yeah, it we all have our own view that's affected by many things, and a lot of it is of distance objects low to the horizon is because of refraction. And yes, Mike, it is a weird enough video. It is a Zetetic Headache for normals, And I did. Oh yes, let me do this. I'm gonna go back to my webpage. So I have here. That's not it. Oh, the evidence. So when you do look at things on the horizon, or things low on the horizon, what does it do to affect it? So let me see. There it is. That's a good one. Did people know the horizon dropped with elevation in 1766? I'm asking that question, knowing the answer. Let me pick the, there we go. So, here is a book for sea navigators. And you can see here it's a table of the depression or dip of the horizon at sea level. So now right here, right here, Zetetic Headache, that one statement there from 1766 flies in the face of item number 2, so-called proof number 2 from Eric Dubé that the horizon always rises to eye level. Right here is a table of the dip of the horizon, because it doesn't rise to eye level. And when you have a quality measuring instrument like a sextant that any sea navigator would need to use to find where they're at, they know this. And so this table here tells them what to do when they're calculating the angular rise above the horizon that some object like a star is, because you use that to identify your position. So you can see over on the right side there we have depression of the horizon of the sea, and it's in minutes and seconds there. So, and then on the left side of that little thing is elevation of the eye above sea level in feet. So 1 foot of, when your eye is 1 foot above sea level, the depression of the horizon of the sea is 57 arc seconds, about 1 arc minute. Not much, but it's there. According to the people that needed to have accuracy in 1776. Now, how could they do that? Well, they had telescopes. They had high quality instruments back then, and they had a lot of budget. So it wasn't regular people that had these things to make the measurements, but because this book was put out by the government of England so that their seafarers could get around, they were able to do that. So now you can look down 100 feet above sea level gives 9 arc minutes, 33 arc seconds of dip of the horizon. So there you go, Zetetic Headache. Maybe you could look into that, do some research, and find out what actually is happening here. How is it that in 1776 people knew that the horizon dipped? And maybe you could use that information there to calculate the radius of the Earth, because there's enough there to give you a pretty good measurement. Of course, you'd need multiple measurements to reduce your margin of error. And the main surveyor, who I put a community comment in my video today, or a community comment today to a video of his where he measures the radius of the Earth. He uses 20 measurements, 2 different days of the dip of the horizon. So 10 on one day, 10 on another day, to get a statistical number and reduce the margin of error. So Personal Atmospheric Dome was a huge alternative hit in the 1980s. All right. Zetetic Headache, who are you for real? Because I think you're kidding around. So thank you for that. And so that is about what I have. I was going to talk a little bit about Sleeping Warrior, and I'll just tell you, he put out a pretty disgusting video today on Conspiracy Cats. I I went in there and I reported his video. So if you want to go in and look at Sleeping Warrior's most recent video addressed to conspiracy cats, where he makes a passing, not quite remark that conspiracy cats is a pedophile, it's pretty rude. And so I reported it. If you think it's report worthy, then maybe it's something you want to do as well. I commented on there because he's saying, of course, as always, that there is no gravity. And multi-tom-tom, you're cute. He says, Russian vids destroyed me on the Non Sequitur show. Well, first of all, do your research. It wasn't on the Non Sequitur show. I was on the Non Sequitur show with Right the Hand, who got kicked off for being a dickbag. And Russian Vids was with me on Fight the Flat Earth channel. So, dude, you don't even know your own model. Yeah, multi-tom-tom, sorry. What is the elevation of the sun above the Earth in your model? Let's do the math to predict where the sun would be, and we will find it doesn't match reality. So anyway, I was talking about Sleeping Warrior and his rude comment. So I put in there a challenge because I have this gravity challenge I'm working on. So I said, look, what is, if gravity doesn't exist, then, and you say it's relative density, which is kilograms per meter cubed, that's what's causing things to go down. But we measure a downward acceleration of 9.8 meters per second. Meters per second doesn't match kilograms per meter squared or cubed. Right there in dimensional analysis, your numbers don't match, Sleeping Warrior. So you failed there. So I asked him, well, what is your prediction? How do you output your prediction to match reality, match observations? And multi-tom-tom, go ahead and maybe give me this same thing here. What is the prediction, the predictive explanation that tells us 9.8 meters per second squared is what we would see? Nobody has ever said that. I've asked plenty of people. Everybody runs away. Just bravely run away, Sir Robin. So maybe you have that, multi-tom-tom. Maybe he's a TEDx headache, which I think you're just joking around. Maybe you have that. Nobody does. Quantum Eraser. He came in and he just did his regular copy paste, which I just said, I'll take that as concession that you have nothing, right? So if gravity doesn't exist, then please explain the acceleration that we measure all over the Earth of 9.8 meters per second squared. You need to have something that predicts that. Otherwise, all you have is negative ice creams. Electromagnetism answers all the gravity questions. Super multi-tom-tom, show me how we can use Coulomb's law to come up with 9.8 meters per second squared. You won't. I know you won't. It doesn't work. Whatever it is, send me, mctoon@mctoon.net, your prediction. You get it right? Well, you can be the hero of all flat Earth, because nobody's done that. Nobody can do that. Coulomb was an idiot. Well, it works. You go tell that to every single computer science or every single electrical engineer, including the ones that designed the computer you're typing on, that Coulomb was an idiot and none of it worked. So, sorry. That computer you're using completely relies on electromagnetism and what we understand of it. So, give me your predictive explanation for gravity that works, 9.8 meters per second squared, and then here's the real challenge. There is a different amount of gravity all over the Earth. It's not just 9.8 meters per second squared. It varies. It tends to be higher as you go to northern or southern latitudes. It tends to be lower near the equator. Why is that? Your model needs to include accurate predictions. People have cataloged these all over the world. They have thousands and thousands of measurements using high precision tools to at least 6 degrees of precision. And we know that it changes. So how does it change? Why does it change? You need to have a predictive model. I have one. I'll go up against you any day, but you won't. You're scared. You got nothing. You're wrong. Gravity exists, and it would pull a flat plane into a sphere. So with that, we're going to head out. I do have one little piece of news. I started a Patreon. It's just patreon.com/sptoon if anybody's interested. I thought a long time about it, and I decided to pull the trigger on it. So whatever. I can pay the bills. But I put money into this. I bought some microphone, bought a camera, got a bunch of stuff. I'm going to go, takes my time, whatever. So, let's see. I am about to go in 20 minutes I'm going to interview the guy building the rocket for Mad Mike Hughes, the flat earther that plans to launch himself to space to see the flatness of the Earth or see the globe. Whatever he might see, Multi-Tom-Tom, I'm sure you're quite excited about that. Oh, you're so smart. He says, Aurora Borealis, Aurora Australis, thunder and lightning all prove electromagnetism. There's no debate about whether or not electromagnetism is happening there. It's whether or not it causes us to go down. You see, when something is grounded, like with a wire, going from an object up high down to an object on, down to the ground, the electromagnetic difference or potential between those 2 points is zero. There's the same voltage. So electromagnetism won't pull something down, yet something up there still feels a pull of 9.8 meters per second squared down. So anyway, Mad Mike Hughes is going to launch himself to space. I had a great time interviewing him. Go check out the interview that I did with him. It's in my Coffee With series. And nobody can get that high, Multi-Tom-Tom. Super. I don't know. What do you think? What's your prediction? Are you willing to put your yourself on the line here? Put your prediction up. What's going to happen when Mad Mike Hughes launches himself up in this rocket that he's going to be in? A flat earther saying he's going to go see the flatness of the Earth from altitude. Anyway, I'm interviewing this guy. He is really, really an interesting guy. And I'm basically just going to let him talk and tell stories. And he has been all around, and he's built tons of stuntmen, cars, boats, rockets. He has the X-15, the engine from the X-15 plane that broke the sound barrier. So, Multi-Tom-Tom, Mad Mike is not a flat earther, of course. Of course he's not, because it doesn't fit your confirmation bias. So, whoa, look at that programming with the globe in the background. That's right, look at that globe right there. Ding, ding, ding. I love that globe. That's what we use for school. And look at this side over here. You can see right there how I prove the Earth is a globe by doing a 270-degree flight path there. Go ahead and disprove that one. All right. That's what I have for this week, everybody. Thanks a lot for joining. I'll have another one next week. I plan to have a guest this time, and trying to get Brian Peck. Well, we'll let you know what that is. In the meantime, I hope to have the video out on the guy building the rocket. And hopefully I can get this $10,000 challenge out. So, all right. How do I stop streaming here? There it is. Okay. Thank you, everybody. Have a good time.